Hi everyone, welcome back. Today we're going to learn how to use LP modeling inside Microsoft Excel to decide the right allocation of ads to maximize the number of people that will be reached. If you haven't done so already, please pause the video and read the problem. Try to get it set up. Remember, whenever we go through the problem, we always want to think about to ourselves, what is our objective? Are we trying to maximize or are we trying to minimize something? What are the variables, what are the decision variables, the things as managers that we're trying to get the answer to, and then of course, what are our constraints? All right, ready? Let's begin. I'll read it along and maybe even highlight as we go through what are the important parts here. So a candidate for mayor has allocated $40,000 for last minute advertising. Obviously this number is pretty important. That sounds like a constraint. That's going to be our budget constraint. Obviously with any project you don't want to go over budget. For last minute advertising in the days preceding the election, two types of ads will be used, radio and television. So imagine you're a consultant, you're the campaign manager for this particular one. You want to know how many types of ads to purchase, and that's going to be the right answer. Like, what is the best possible combination of ads to buy here, radio or television? So for our variables, our decision variables, we can start creating this and typing this away here. Let's think about what we want to do. We need the number of radio ads. And we'll be very clear about what we call this. It's okay if they're long names, but I'd rather be clearer than not. And also the number of TV ads. A couple things here. It wouldn't be, I mean, I get what you mean, but if some people just put radio ads and TV ads, remember Excel doesn't read, Excel doesn't do, I don't know, English or other languages. It needs a number. So I need the number of radio ads, the number of TV ads. The more explanation, the more words, the more clarity you can provide in your spreadsheet, the better. We can always make it look prettier later or rewrite things, but at least in the beginning, I've seen a lot of people just say radio ads, but they don't recognize that I need to fill in a number. So I'm going to color these decision variable cells green, as is custom. And remember, I like to put in some dummy numbers here, just so I can make sure the spreadsheet is working. So let's pretend the answer is, 4 and 5. I don't know. Maybe it's not, maybe it is. I got lucky, you doubt it, but we'll see. Okay, so let's keep going. Each radio ad costs $200 and reaches an estimated 3,000 people. All right, so cost is going to go associated to my budget, and that's going to be a constraint, so maybe I'll start building that here. So we build our little constraint table down below, and we're always interested in our objective. This will go here. We want to maximize, hopefully you read this and you saw this, but we want to maximize the number of people reached. So I like to put in parentheses what I'm after here, just as a max. I have my variables, I have my objective, I have my constraints. So let's start putting in the constraints. Always label your constraints. I don't want to refer like, oh, the first constraint. That doesn't make sense. Here I have a budget. So the way we're going to set this up in our table is we're going to think about a table that goes three cells, 3 columns past the variables. So here I have 2, so I'm going to go all the way out to 5. So my table is going to be, let's see, I don't know how long it's going to be, or I say how many rows it's going to be, but it's certainly going to be 2 for the variables and then 3 past. And we always label the cells with the left-hand side, the sign, and the right-hand side. So I'll abbreviate LHS for left-hand side and RHS for right-hand side, and the sign's going to be here. So what do I mean by this? How does this work? Think about if the answer is 4. If you purchase 4 radio ads, right? This is why we have dummy numbers so we can actually talk about it. It's going to cost you $200. So my budget cost, well, obviously I'm going to have my radio ads and my TV ads. It's going to be $200 times the 4 radio ads that I purchased. This is just an example here. I don't know if this is 4 is the right number or 5 is the right number, but I have 4 here. Then what else do I need to purchase? Well, I'm going to buy 5 TV ads. Well, how much do those cost? Well, they cost $500. So it's $500 times 5 TV ads that I bought. And then you calculate whatever that is. And you have to ask yourself, is that less than or equal to the actual budget? Did you go over budget? Always make sure that you didn't. And you want to just sort of check, is that okay? This is becoming a little bit of a math equation, even an inequality, but we want to multiply the cost, 200, by the number of radio ads purchased. Hopefully that makes sense. If I buy 4 radio ads at $200, I multiply them together. So what you do is, again, only put in numbers. Excel likes numbers. Let's put $200 for the cost, the coefficient on the number of radio ads, and then $500 for the number of TV ads. The left-hand side, this is a calculation. This is a number that's computed. This is actually a formula. Okay. This is a formula. And what's it going to be? Now, I could sit here and click 200 times 4 plus 500 times 5, but in Excel, there's a faster way to do that. Let's use the sum product formula. The sum product says, I will sum and multiply these as you go. You can highlight the two arrays, 4 and 5 go together, and then 200 and 500 go together here, and you hit enter. You can check that 200 times 4 plus 500 times 5 is 3,300. Let me remove this, and I'll actually put the formula text in here for the left-hand side, just to show you this is. This is the only formula in our constraint table. This is the only formula that we're going to use. Everything else here is going to be a number. The sign corresponds to, do you want to be less than or equal even, or greater than, doesn't matter, but we want to be less than or equal. It's okay if we spend all our money, the money's there, but the key is you don't want to spend money you don't have. Okay, so our formula for the left-hand side is a sum product. One more time, how's it working out? Just a shortcut. I also want to, just for good practices, let me put dollar signs here. Let me do my absolute referencing. So I'll use the keyboard here to do that. That's function F4. Hit enter, and that'll lock it in. Notice it doesn't change the values. It'll just set me up if I want to drag this down if I have other constraints. Good practice. I don't want to lock in my cells, the 200 and the 500. That could be problematic because I do want this to scroll down as I go. So we'll do our formulas with dollar signs. And then the right-hand side is just the budget. What do I want to be less than? 43. Remember, I typed the numbers in naked. Don't put the commas. Don't put the dollar signs in. Just type the number. If you want to format it to dollar signs, you certainly can, although you don't have. So that's what this constraint looks like inside of Excel. Notice every cell gets a number. We don't type in equations. We don't type in sentences. Excel doesn't read. Can't do it. All right, so let's keep going. So each radio ad costs $200. That 200 is now in my spreadsheet, and reaches an estimated 3,000 people. So now my objective, this is a new one here. I want to maximize this number. What is the thing to maximize the number of people? Each television ad costs $500 and reaches an estimated 7,000 people. So what you do here is you put the coefficients for each one underneath. So let's do that. Coefficients for objective. Like what's the point? What are we trying to do here? What do we want to maximize? Where you put this, it doesn't actually matter, but it would just only put numbers as a reminder. So the radio ad reaches 3,000 people. There you go. And the number of TV ads reaches 7,000 people. Those are obviously important numbers. They should go somewhere on my spreadsheet. We tend to put them right below the variable they correspond to. Then the objective, the max, which let's be more clear, the number of people reached. It's okay if you go over, just make the column wider, no big deal. Keep pretty spreadsheets going along here. This is our objective cell. This is the thing that we want. This is the answer. How do we know we have the best possible way to do this? We usually highlight this gray. The colors may change, but just highlighted something makes it easier to find. Throughout the video series here, we will highlight it gray. Now, how do I know how many people it will reach? Remember, each radio ad reaches 3,000 people. So what do? You multiply that up. And then each TV ad reaches 7,000 people. So what do? You multiply that up, and then you add them together. You could do it by hand, but let's get fancy. Let's use the sum product formula. I'll take 4 and 5, and then I'll do comma, 3,000, 7,000. Hit enter when you're ready, and you get the total number. You can format it, make it a number, make it all pretty. Since this is people, we don't need decimals here. Maybe I'll add a comma. And now I can really test if this spreadsheet is working. Watch, if I change 4 to a 7, all the numbers should change. And you can, of course, check this offline just to make sure that this is actually working. So whatever the numbers are going to be. So let me put back my 4. But you can see the spreadsheet was working. If I misclicked by accident, having these dummy numbers in there will help me find that as I go along. All right, so anything else? Now, she has stipulated that at least 10 ads of each type be used. Stipulation, a request, a requirement, that all sounds like a constraint. So let's go to the drawing board for a second before I actually put that in here. I have my at least 10. Now, this is actually two constraints. At least 10 TV, and then, of course, at least 10 radio. What does that mean? So the number of radios, here just my dummy variable is 4, this should be at least 10. Which one do I want? Do I want less than, or do I want greater than? What's the right one? If I want to be at least 10, be careful. English is a tricky language. If I want to be at least 10, it means I need 10 or 11 or 12. I need to be greater than. So the one I want is greater than 10. And of course, my TV ads here, my TV needs to be greater than or equal to 10. So let's think about how we would set that up here. So let's label our constraints. At least 10 radio. at least 10 TV. And how am I going to copy, how am I going to count down? I really want to use sum product one more time. So whenever you want to just kind of copy the number down, you just want that 4 to appear, like test if it's a 4, you can multiply by 1. You think about it by 1. So if I put a 1 here and a 1 here, watch what happens when I multiply them together. I'm just going to drag the formula down, and I will drag the formula text down so you can see it, what's happening. Notice the left-hand side, the thing that I want to test, the 4, how is this calculated? This is the sum product of what? 1 times 4 plus 0, when it's blank there's a 0, 0 times 5. Convince yourself that 1 times 4 plus 0 times 5 is actually 4. And for all the same reasons, 0 times 4 plus 1 times 5 is just 5. So whenever you just want to count, or you just want the number to appear, you just want to check against the number, you put a 1 in there for the coefficient. And here, at least would be greater than or equal, and then we put in our constraints. Notice the sign column and the right-hand side, RHS column, are just numbers. The formula, the only calculation that has to happen, and it's the same calculation every single time, comes from the left-hand side. All right, what else? So each television ad is $500, reaches an estimated 7,000 people. The campaign mayor would like to reach as many people as possible, but she has stipulated that at least 10 ads of each type be used. We took care of that. Also, the number of radio ads must be at least as great as the number of television ads. Oh boy, another requirement, another stipulation. Let's go to the drawing board and try to figure out what that actually means. The number of radio ads must be at least as great as the number of TV ads. Where can I work on that? So let's put this down here. So this is the radio ads must be at least as great. So they have to be sort of greater than or equal to TV ads. I'll use R and T to denote those variables. Okay, so this is fine, but we're going to do a little bit of rearranging here. Normally on the left-hand side we have a number. You can do it, but we like to be consistent. We want the T to be on the other side. So let's go back to a little bit of basic math here. You can subtract T to both sides, and you get R minus T is greater than or equal to 0. These are exactly the same constraints. This is saying when you have two numbers and their difference is positive, it's saying that R is bigger than T. Stare at that for a second, think about that, convince yourself that that's true. And now what do you do here? You grab the coefficients. So what are my coefficients on the variables? Well, when I have variable by itself, it's like 1, and then of course this is minus 1. So those are the numbers that are going to go into our constraint table. You always grab the numbers. Do not, it is very common, but I guess understandable, do not enter letters or sentences or variables in these cells. Some people put R, some people put minus T. That doesn't make sense. So we want 1 and minus 1. But that's where it's coming from. These numbers, these coefficients on the variables represent the equation. I copy down my formula. One more time. There it is. You can pause the video if you want to see it. This should make sense. I'm always grabbing my variables, the 4 and 5. Again, these are probably not right. I'm just taking a guess here. But I just want to make sure that everything's working. Let's give this constraint a name. So we'll say R greater than or equal to T. You can do something better if you want to. It's just there to remind you what it is so you can talk about it if you're checking. The inequality here is less than, greater than or equal, one more time. And then here, I actually want this to be 0. That comes from rearranging the sentence. So you always want a number on the right. You try to do it with a number on the right. I'll copy the formula text down to show the actual formula in the left-hand side. And now I think we've gone through. So at this point, we would read it one more time. We would check it like crazy, make sure we didn't miss a constraint. These constraints come at you in any particular direction. There's no rhyme or reason to them. So just make sure we feel good about it. Okay, I think we're good. Next, now I want the right answer, right? So now you can play the game like, what is the right answer? If I have 1 and if I have 6, I can reach 45,000 people. Is that good? I don't know. Let's play. So that one radio ad would cost me $200. 6 at $500 each. Well, that would be $32,000. That's well under my $40,000. I could probably go higher. So if I go higher, why don't I just do 10 ads here and maybe 20 ads here? Okay, so I'm still under budget, but I have some problems here because I'm failing the fourth constraint. Right, the number of radio ads is not, see this negative 10 here, this would not be greater than or equal to 0. This particular answer wouldn't work. It's not an answer in our feasible region. So we really want to find the best answer. This is where you can kind of see the power of Solver. Solver is going to find the best answer that will maximize this, satisfying all the constraints. We don't really want to sit here and guess and check and say, well, it's the best number that I could find. We'd like to guarantee that it is the best. So here we go. Data, Solver, and the pop-up box always looks the same. Let's go through. We're just going to go top to bottom here. We set the objective. The spreadsheets are going to get more complicated. They're going to get larger. Color coding really helps with this. It is always the gray cell. Click the cell. For me, it's B5. Then I want to, remember, you can always minimize it. You don't want to minimize the number of people reached. That'd be pretty bad. So we just make sure we have max min selected here. I remind myself in the spreadsheet that it's a max. And the variable cells, those are our green ones. So color coding helps do that. So we highlight the green cells inside of the box. So 1, 2, 3 things are set. Now, subject to the constraints. Inside of here, inside of this box, we hit add, and we get these 3 little boxes pop up. This is going to be our left-hand side, our sign, and our right-hand side. So the left-hand side is going to be 1200. I can change the sign. It's a drop-down, so you can always change it if you need, but here it works out quite nicely, less than or equal. And the constraint, don't type anything. Never type anything. Just click. You can always make a mistake if you type it, so just click that as you go. And then we don't hit OK. It'll actually take you back. You only hit OK at the very end. It's a little confusing, but you hit add, and we'll do another one. We'll do the left-hand side, and now it is greater than or equal to the right-hand side. Right, so it lines up with our table. These are the 3 columns that go after our variable cells. Let's add another one. So our left-hand side is going to be this 20 that's showing here, greater than or equal to the constraint. Let's add another one. One more, last one. We take our left-hand side. It is greater than or equal to our constraint. And we can check this at the end. It's obviously easy to select the wrong box, but hit OK when you're all done. And there they are. So 1, 2, 3, 4 corresponds to 1, 2, 3. Notice your ability to sort of do Solver, to put the parameters, put the constraints in the Solver, is only as good as your spreadsheet. If you missed one of the constraints, if you typed in the wrong number on your table or did something like that, then Solver is going to be wrong, and the spreadsheet is going to be wrong, and you're going to get the wrong answer. So this is why you have to check along the way as you go. All right, other things that we could do, if you had to change it or delete it, they're all here. If you wanted to just start over, you could reset all. This is a checkbox that says make all constrained variables non-negative. That's saying that can these variables be non-negative? Should they always be 0 or above? You can certainly come back and say, I don't want any radio ads. I don't want any TV ads. Perhaps that's the right answer. Who knows? But you certainly don't want to come back and say, I want -4 radio ads. I definitely don't want them to be negative. That normally doesn't make any sense to have negative in these word problems, so it's by default checked on Solver, and we usually just leave it checked. It would be really weird if you came back and said, I want -3 radio ads and -2 TV ads. You might not hold on to that job for too long. So again, make sure this is checked. All right, select a solving method. We're doing everything LP, linear programming, so please select simplex LP. These other algorithms are sort of not appropriate for this problem. We'll talk about them later in the course, but simplex LP is the one that you want. And when you're ready, you think everything's good, you hit solve. Depending on your computer, it could be a little slower, a little faster, but here's what you want. Solver found a solution. All constraints are optimally satisfied. So we keep the Solver solution, we say OK, and we hit thank you, and we're good to go. Now this is amazing. Appreciate what Solver has done. It's come back and says the best possible answer that you could find is 175 radio ads and 10 TV ads. You can check. If you were guessing before, as we were, if you want to go back and look when I plugged in some random numbers, I did not get this answer of 595. My answer, which even wasn't even feasible, wasn't even allowed based on the constraints, was much lower. So this use of Solver takes away all guess and check work. It is the best possible answer. It removes that gut feeling. It removes, that sort of, I think this is the best one, and gives you that confidence to say this is the best one. And this is a wonderful tool to have, to master, to be able to build these spreadsheets, because you can imagine going against a manager or some other colleague with experience, and this is how we've always done it. Oh, the worst possible answer. I hate hearing that. But you come back with a more analytic approach. You can defend your spreadsheet, you can defend the model, and this will be the best answer. So this is really nice. The one thing that I'd like to have my students do is at the very end, I do something what's called a summary sentence, because it's one thing to find the answer, but then it's another thing to communicate it back. A lot of people don't realize what they actually have, what they're holding. So remember what you're doing here. Let's answer the actual question. the number of radio ads. So we should purchase 175 radio ads, 10 TV ads to reach a maximum of 595,000 people. So here's where you would watch your units. Here's where you'd actually present the answer. You can imagine writing an email to your boss and sending the spreadsheet, perhaps as an attachment as needed. You would never just send someone a spreadsheet without any explanation of what's going on. So this summary sentence is extremely important. It reminds you of what you found, just helps you to remind yourself of the units and does everything make sense. Did I stay under budget? I spent all 40,000. Do I have at least 10 radio? I certainly do. 175 is larger than 10. Do I have at least 10 TV? Yes, I do. The bare minimum here. And is the number of radio ads larger than the number of TVs? Absolutely. Thank you, solver. Thank you very much. Here's my answer, 595. All right, fantastic. So this is a very simple example. I really want you to master this one. The constraints are pretty straightforward. You can imagine, how does this get more complicated? We could introduce more complexity in the constraints. The numbers can get larger. We can have more variables. There's lots of ways to go from here. This is the first level, first foundation. Start here, master this one, build it again from scratch. If you got something very similar, could you do it? Save this model as a template for linear programming. So if you want, just call this like LP template or something. From here, all things will grow. We'll have more constraints go down. We'll have more variables going across. And of course, the problems will get a little more complicated as we go. All right. Great job on this example. We'll see you next time.